Hi guys, this is Mrs. Jordan. So today's video is for day 2 of your math packet on week 1. You may have watched Miss Haley's video first. She goes through the packet about area and shows you how to find the area and make specific square footage for different exhibits in a museum. So this video is going to be me helping you break down area a bit further and just simplify it a little bit just to get some practice, and maybe after you do this video with me you'll be able to go back and try the packet with Miss Haley or by yourself, and you'll feel a little bit more confident with that. Okay, so let's first talk about what area is. I want you to think about it for a second. We talked about this concept of area this year. What is area? Okay, hopefully you're thinking right now, and you might be thinking, well, I remember that it's length times width. Awesome, that's correct. Another thing, so area, if we're finding the area of a shape, say a little rectangle like this, area is everything that's inside. So if we wanted to know the area of this shape, it would be how big is the inside of this shape? How much can fit in the inside? That's the area. So in the packet, it says the area of a certain exhibit is, say it says 12 square feet. What that means is the inside of that exhibit, where all the different, people and plants and everything like that in the exhibit, it takes up exactly 12 square feet. So there's 12 boxes that it takes up all together, so you could count them. So what you need to find out from there is, what are two numbers that you could multiply that would equal 12? So you could be thinking, okay, well, maybe I can find the factors of 12. So let's see. Let's start with an easy one. 1 and 12 is 12, because any number that looks in a mirror is itself. Okay, how else can we break down 12? Well, I know 12 is an even number, so it has to be divisible by 2. Let's see how many times we can multiply 2 to get to 12. 2, 4, 6, 8, 10, 12. Okay, 6 times. So 2 and 6. All right, and there's actually one more. It's going to be 3 and 4. So now that we've figured out all the factors of 12, we know these are going to be all the possibilities of what the length and width could be for this exhibit. So the answer to this could be, well, the exhibit could be 1 foot by 12 feet. That would look super thin and skinny like this, right? It's only 1 foot of width and then 12 boxes of length. Or it could be 2 boxes by only 6. That would be a little bit thicker. Or we could do 3 by 4. Like that. Either way, make sure there's 12 boxes on the inside. So this one is the 3 by 4, this is the 1 by 12, and 2 by 6. Like that. Okay, awesome. So let's try another one. So what if I told you that there's an exhibit at the museum? Here it is. And this exhibit is 8 feet by 10 feet. Take a second and think about this. What do you know about this problem so far? Okay, so what you should be thinking right now is that you know the dimensions, which means you know what the length is. Here's the length. And you know what the width is. which is exactly what you need to find the area. So you should be thinking, I have all the information I need to find the area of this problem. So, if you remember in class, the other thing we talked about with this is that if you know this is 10 feet, you know that this side up here is also 10 feet. That's just helpful to know in case you need to find perimeter. Remember, perimeter would be the whole way around. Right now we're focusing on area, but it's just good to know. So again, if this is 8 feet, over here would also be 8 feet. Because it's a rectangle, so you know the opposite side is going to be the same length. Okay, so how would we go about finding area at this point? So we know the formula for area is what? Hopefully you're saying length times width. So you know the area is length times width, so now we just have to plug in our numbers. So we're finding area in our equation, and we're going to plug in whatever the length is multiplied by whatever the width is. So in this case, it's 8 is our width, and 10 is our length. Okay, so now final step is we're going to find that area. So we just have to multiply these two numbers. There's a couple ways you can do this if you don't have it memorized. So the first way is doing your zeros trick and then using your knowledge of 1. So if I were to just block out this little 0, I'm looking at 8 times 1. Anything that looks at 1 is like it's looking in the mirror. So you should know that 8 times 1 is 8. And then you just have to add that 0 afterward. So it should be 80. And up here I use the unit of feet. So I'm going to say feet squared. Because I'm talking about how many little squares can fit in this exhibit at the museum. So another way, I'm going to show you another way to multiply this in case this way is a little confusing for you. So this way is going to take a little longer, but it's going to get you the right answer. So I'm going to draw 8 circles. And each circle is going to get 10 dots in it. Just to keep it straight, I'm doing 2 rows of 5 in each. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so I filled in 8 circles, so you just pick one of the numbers to start with. I picked 8, and that's the amount of circles or spots you're gonna do. And then within those circles, you do however many dots are in the other number, which is 10. Okay, so this is representing what this multiplication problem is. It's showing there's 8 sets of 10 dots, which is a lot. That's what multiplying is, making it much bigger. How many sets of, how big would it be if you took 8 different sets of 10? So that's like counting by tens 8 times. So if I were to count up every dot, it's like going 10, 20, 30, 40, 50, 60, 70, 80. So you should, again, for the area, get 80 square feet. Okay, awesome. This next one, I want to challenge you to try to pause the video and try it on your own first, and then you can play and try it again with me so that hopefully by this point you're able to do it on your own. Okay, so for this one, we're going to do another one like at the museum. So we're saying that the area of an exhibit is, let's say, 20 square feet. And again, don't be scared by that unit. That just means in the square exhibit or rectangle exhibit, you could fit 20 1-foot squares in it. Boop, 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 boop. So we're trying to figure out what are all the different ways we could line up 20 squares together. Okay, so pause it. I want you to try this on your own. What you're doing is you're finding what are all the ways you could break up the area of 20 square feet. So what are all the combinations of length times width? So you could make a chart like this to help you figure it out. Just a simple, you know that area has to be 20. So what would the length and width be? What are all the different combinations that you could multiply to get to 20? Okay, so pause the video. I want you to try it. Okay, hopefully right now you've gone through it and you've tried it yourself. Hopefully this will help you see if you did it right and answer your questions about it. So, first thing, I'm gonna make a factor tree. So I'm gonna break up the number 20 into as many factors as I can. Factors are just what you can multiply to get to the answer or the product. In this case, it's 20. So the first one I'm gonna do is the simplest, always. You can always multiply any number itself by 1. So that's always going to be a factor. Sometimes that's the only factor, and that's when you get a prime number. But in this case, I know that 20 has multiple different factors, so it's a composite number. So every single number is always going to have 1 and 20. So when you're doing factors, go ahead and do that one first, because you know it's going to have to be a factor of every number. Okay, so we have 1 and 20. So that right away, I could fill that in over here. I know that you can do the length as 1 and the width is 20, and that would give you an area of 20. So that's one answer right away. You're already done. And you could flip-flop that too if you wanted. You could do the length is 20 and the width is 1. It would still give you 20. Okay, great. What else do we got here? Well, another easy way is you see that 20 happens to also be an even number. So what that tells me is that it has to be divisible by 2. 2 goes into all even numbers. And even numbers are anything that ends with 0, 2, 4, 6, 8. So in this case, it ends with 0. So I know 2 goes into it. So if you can't think off the top of your head, what could you do twice to get to 20? You could count by 2s and see how many fingers it takes to get to 20. So I'm going to do that to help you. Okay, here we go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Oh, 10 fingers. Okay, so it's 2 and 10. All right, let's keep going. Is there any other? Well, another cool thing is if something ends in a 0 or a 5, it's divisible by 5. And all that means divisible, it's a big word, but it means it can be divided by 5, meaning 5 is a factor of that number. So we can count by 5s and see how many sets of 5 can go into 20. 5, 10, 15, 20. Okay, 4 sets of 5. Perfect. And you know what? I know I'm done now because 4 and 5 are numbers that are right next to each other. They're super close on a number line. And so there's nothing else in between that I could go. See how I did these in order? 1, 2, 4, 5, 10, 20. Okay, so I'm just going to fill in the rest of my chart here with all these answers that are possibilities. So we did 1 and 20 already. Let's do 2 and 10. So the length could be 2, the width could be 10, or I could switch it, 10 and 2. All right, and my last one we have length could be 4, width could be 5, or we could switch it. Length could be 5, width could be 4, and it would still give you 20. Okay, so you have 1, 2, 3, 4, 5, 6 different answers. So I'm going to go ahead and draw these out for you to finish it up, just to show you what they would look like. So if I had a exhibit that was 1 foot of length, so super tiny, just 1 little foot, and 20 of width, let's think about what that would look like. It would be like this. 1 tiny little foot and then 20 long. And then if I flip-flop that and do 20 by 1, it would just look like this on its side. Here we have 2 by 10. You're just going to make it a little thicker. And then we have 5 by 4. And that one's going to be the closest thing to a square. It's still not a square because a square would have to have the same... It would have to be the same number on length and width. Okay, I hope this helped. You can pause it and rewatch it if you need it, and we'll check back in later.